Now we're going to talk about how to solve exponential equations. So how do we solve equations where the variable is in the exponent? So first we're told, if it's convenient, express both sides with a common base and set the exponents equal to each other. So if you can get it so that you have the same base on each side, and that's all you have, you can just set the exponents equal to each other. So let's look at example number 1 here. Here we have 5 raised to 2x minus 5 equals 125. And 125 happens to be 5 cubed. So if we do 5 cubed, we see that it's 125. So we can rewrite this as 5 raised to 2x minus 5 equals 5 cubed. So what this is saying, since we have the same base on either side, we can now set the exponents equal to each other. So we're going to say 2x minus 5 equals 3. Then that's just a simple linear equation we can solve for x. So we're going to add 5 to both sides. 2x equals 8. Divide both sides by 2. X equals 4. Okay, we can also do the similar thing with the next one. We have 16 raised to the x equals 32. Now 16 is 2 to the 4th, so we can write this as 2 to the 4 x equals, and 32 is 2 to the 5th, right? So if you just want to check those, 2 to the 4th is 16, and 2 to the 5th is 32. Well, then we would just say 4x equals 5, so x would be equal to 5/4. Now, we'll learn the next thing to do if you can't raise it to powers, and I'll show you how it works here, just in case you don't easily see that 16 is 2 to the 4th and 32 is 2 to the 5th. So, if you can't express both sides with a common base, it says otherwise take the natural log of both sides and use the power rule. So what we're going to do is we're going to start off with our 16x. This is just another way to do it. We'll get the same answer, equals 32. And we're going to take the natural log of both sides, which means we're going to say natural log of 16x equals natural log of 32. Now notice what natural log does, remember the power rule, says that we can bring this exponent down in front. So we can rewrite this as x natural log of 16 equals natural log of 32. And now to solve for x, we just need to divide both sides by natural log of 16. So x equals natural log of 32 over natural log of 16, which we can put in our calculator. So natural log of 32, close your parentheses there for the natural log, divided by natural log of 16. Okay, and we get 1.25, which if we change to a fraction is 5/4. So you'll get the same answer. The second way always works, so even if you could have expressed it as the same base, but you're just not quite sure what base to use, taking natural log of both sides works. And the reason we like natural log is a lot of times we'll have, you could actually use log of any base, taking it both sides, but we like natural log because in a lot of applications we're going to see exponential functions where the base is e. And as we see for this next one, natural log and e cancel each other out very nicely. So here we have e raised to the 0.05t equals 1500. So we're going to take the natural log of both sides. Natural log of e to the 0.05t equals natural log of 1500. Now the power rule tells us that we can bring this whole exponent down. So that's going to be 0.05t natural log of e equals natural log of 1500. Well, remember, natural log of e is just equal to 1. So here we would have 0.05t equals natural log of 1500. And now we want to divide both sides by this 0.05. So we're going to have t is equal to natural log of 1500 divided by 0.05. And that's something you can do on your calculator. Okay, and let's round to 2 decimal places. So t is approximately 146.26. Okay, and we can use this process of taking natural log to both sides even if we have exponents on each side. So here we have 5 raised to the x plus 2 equals 3 raised to the negative x. And we're going to take the natural log of both sides. So natural log of 5 to the x plus 2 equals natural log of 3 to the negative x. And now on both sides we can use the power rule. In the power rule, we bring down the whole exponent, and we'll actually put the exponent in parentheses if we need to. So that will make this x plus 2 natural log of 5 equals negative x natural log of 3. Now, here we're going to have to do some algebra to solve for x. The first thing we're going to do is distribute the natural log of 5 to the x and the 2. So we'll write it as x natural log of 5 plus 2 natural log of 5. Now, since we are trying to solve for x, we need to get both terms with x on the same side. So I'm going to subtract x natural log of 5 from both sides so that I get the natural logs both on the right side. So I'm going to come up here, and this will be on the left-hand side, we'll just have 2 natural log of 5. And then on the right-hand side, we'll have negative x natural log of 3 minus x natural log of 5. So now we have all the terms with an x on the right-hand side, and we can factor out an x. So I can write this as x times, well, if I pull out x out of this term, it's negative natural log of 3. If I pull an x out of here, it's negative natural log of 5. And now to get x by itself, I just need to divide both sides by negative natural log of 3 minus natural log of 5. And I know it looks a little crazy. What we have here is x equals 2 natural log of 5 over negative natural log of 3 minus natural log of 5. And we're going to put that whole thing in our calculator. So we're going to do 2 natural log of 5. Now since we have more than one term in the denominator, we need to start a set of parentheses. And we're going to do negative natural log of 3, close the parentheses for that natural log, minus natural log of 5, and we see that x is approximately negative 1.19 if we round to 2 decimal places.